Welcome back to the channel. Today we'll do benchmarking of AI models like Mistral and Phi from Ollama. It would be an interesting session. So let's get started. Now, before we dive into the code, let us quickly talk about the LLM benchmarking. Well, not all AI models are created equal. Some are faster, some give better quality answers, and some balance both. Benchmarking helps us measure things, response speed, and accuracy, so you can choose the right model for the job, whether that's coding, summarizing, or just chatting. So, in this video, I'll show you how I use Ollama with Python to benchmark two models side by side, log their responses, score them against reference answers, and even visualize the results with charts. Let's break it down step by step. First, we import the necessary libraries, Ollama to run the model locally, time to measure the response latency, CSV and pandas to store and analyze the results, Matplotlib for charts, and then NLTK for BLEU scoring, plus the Rouge score library for Rouge L score. Next, we set up the module list. So right now I'm benchmarking two models, Mistral and Phi, but you can easily add more here. Then I created benchmark dataset, basically a list of prompts and their ideal answers. For example, explain quantum computing in simple terms, summarize the importance of renewable energy, and for each prompt, I have written a short reference answer. This reference will be used to check how close the model's response is. Now the script writes the results in a CSV file. We set up columns like model name, prompt, response, latency, BLEU, and Rouge L. Then comes the fun part, running the benchmark loop. For each model and each prompt, we send the prompt to Ollama, measure how long it takes, capture the model's reply, and then compute BLEU and Rouge score. BLEU checks words overlap between the model's response and the reference, and Rouge L looks at the longest matching sequence. So it's good for summaries. After collecting the results, the script appends them into a CSV file. So for every run, you will have a nice log of which model said what, how long it took, and how well it scored. But that's not all. We also load everything into pandas, add a summary row with averages, and save it back into the CSV. So at the end, you get something like this: model name, average latency, average BLEU, and average Rouge. Super handy if you want to quickly compare different models. Finally, we generate some visual charts, latency versus BLEU and latency versus Rouge. These scatter plots show how each model balances speed and quality. For example, one model might be faster but less accurate, while another is slower but gives better answers. First, let us pull both the LLMs for our benchmarking in local. I already had downloaded both the models, so it was quick. Let's run the code in VS Code. I shall give the GitHub link of this code in the description. Okay, now you can see the latency versus BLEU score visualization is created for different LLMs, in this case Mr. and Phi. Also, the latency versus the Rouge L score. You can also observe the benchmark results are saved in the CSV file. And that's pretty much it. We just a few lines of Python, and you can see we have built our own mini benchmarking framework for LLMs. It's flexible, easy to extend, and gives you both numbers and visuals to compare models. You can expand the script with more prompts more models, or even additional metrics like perplexity. So, if you are curious about which model is better for your use case, whether it's speed or accuracy, this kind of benchmarking can really help. All right, that's it for today's walkthrough. If you found this helpful, don't forget to like, subscribe, and drop a comment if you'd like me to add more advanced evaluation techniques in the future. Thank you.